All right. All right. All right. Hope everybody's doing okay. Uh, we're a month out from the final, I think. It's getting hot, yo, real hot. All right, for today. Hopefully people are still coming. I think they are. Homework that's coming up. It turns out, I think I remembered this last night, and I was like, yeah, screw it, I'll do it in the morning. So I'm doing it right, and I did it this morning. Turns out I didn't give you guys anything for chapter 6 to do when you guys could have been doing it. I put all that stuff up already. I give you guys some extra time to do it. I think all of it's due, I think, next week. Or maybe this week at the end. Since we're still on it, you guys aren't too far behind on it. So you guys can still do the lecture videos and whatever else, and the assignments online. So yeah. Labs. So I screwed up there because I never made anything past chapter 3 or 4, I think. So that was entirely my bad. I did mean to give you guys labs. Since we moved online, that's one of the things that like completely fell off my radar, and I just picked it up again. So you guys are in chapter 6 right now, still not quite done with it. So what I'm thinking of doing is making you guys your lab for chapter 5. It's going to be nice and short. Chapter 6, we're on it. So I'll make that lab in a little bit, probably later on today. And then the same thing for chapter 7 and 8. I think I'm going to combine those two into one big, huge lab. Chapter 8's not too long. Chapter 7's the big, like, sort of like the beefy bit. So I'm going to do chapter 7 and 8, probably both together, which leaves chapter 4 that I haven't given a lab for. And my thoughts there, I think I'm going to make the chapter 4 lab, but since it's way, way, way behind, like that's now like a month behind, I'd probably go ahead and grab that and make it an extra credit. If people want to complete it, then great. If not, since that was a heavy section to begin with, then it won't hurt your grade. But seeing that I think I can make it an extra credit assignment, I think most people would want to do it. So yeah, housekeeping. Every time I say that word, I'm reminded of Chris Farley for some reason. For those of you who can remember Chris Farley, housekeeping grading. I am so behind. So I've graded everything up to maybe chapter 3, which is the stuff that I had on me before we went on to lockdown. It's graded. It's got a number attached to it. People did okay on it. I just need to sit down and put that in to the computer, and that's what takes the longest, mostly because of how slow Canvas is to load stuff. So yeah, I think I'll have all that stuff hopefully in by the end of today. I'm going to concentrate a lot on you guys for today, and get as far caught up with you guys as possible. Hopefully start grading the online stuff that you guys have been submitting, hopefully submitting. And in the meantime, under the same sort of, while I update your guys' grades for chapters 2, 3, and 4, start turning those assignments into the online submission. So if you haven't turned in stuff from like a month and a half, 2 months ago, I'm going to be making them go online so that I can give everybody the opportunity to turn something in for them. Okay. Like I said, hopefully that'll happen by the end of today. Exams, I think I've gotten through almost all of them. There's just a couple that are left where I'm hunting down how to open your guys' attachments. I didn't want to limit your guys' I didn't want to limit what you guys could submit. So, for example, the hardest one is some of you guys have iPhones, and you guys submitted pictures from an iPhone and leave it to Apple to assign it a specific file format that only Apple can open. So I had to go hunt down a program to open your guys' files. It took pretty long and a lot of testing, but once I found one that actually works, hands down, simple, it ended up working out. Okay. So hopefully, again, by the end of today, I think there's maybe like a handful, I'd want to say like 2 or 3 exams that are still left without grading. That I just need to get through. Once that's in, everybody else, I think I'd be done with grading. So for now, maybe you guys have probably seen that your grades have sort of gone up and down your grades have gone up from your exam. So that was me grading. So if you've already seen that, then that means I'm done grading with your exam. There's only a couple, like I said, that I need to get through. So I'm almost done with those. Old work, turn it in. Old work, turn it in. I'm gonna start looking at it pretty soon. Really, really soon. I keep saying that, but I think I've taken care of all the essential immediate stuff, which means I can now start hitting those long-term things, which are the old assignments. So that's that chapter 4, the chapter 5 material that needed that we've just been doing. Make sure you get that in. Okay. Yeah. Are there any questions from you guys before we keep moving on, before we keep trucking on?
I do.
What you got?
I was looking at packet. It was chapter 6, section 1.
Yeah.
Quick check 2 towards the end before the London Eye thing. Why did you add the period and phase together?
Which one? Say that one again.
Quick check 2 towards the end. The one before the London Eye, right there, says phase shift plus period. Why'd you do that?
Okay. So the phase shift told you where to start, right?
Yeah.
Makes sense. The period told you how far to go for one squiggle. Does that make sense? So what I did was this. So let me actually give me a. So, okay, so how about I explain it this way? The phase shift, I'm going to do it over here. Okay, the phase shift sort of tells you where you need to start. Does that make sense? So we know that we needed to start at 1/4 to the left. So we needed to start there, minus 1/4, right? And the period tells us how far we need to go. Now, if we just use the phase shift, it only tells us where to start. It doesn't tell us where to end. Does that make sense?
Yeah.
But I need one squiggle, right, to fit in. So this is supposed to be one period, right? And we know that this thing is a cosine graph, right? So we know that this is going to happen, right? We know something like that, right? And it needs to end somewhere, right? But we don't know where this is, right? That's where this calculation comes into play. So I started at negative 1/4. I added one period. So that 2 that you guys see here, right, is from the period.
Okay.
Which is 2 right there. Make sense?
Yeah.
So I know that this one period that I need to do, that I need to take into account, is 2, right? So then I added where I'm supposed to start from, minus 1/4, and I added a period, plus 2. And I got that thing at the very end, the 1 3/4. That's what tells me, like, so now these question marks that are back here, I know now that that's 1 3/4 or 7/4, right?
Okay.
So that's why I added the period.
Okay. All right.
Yeah?
Yeah. All right. Thank you.
I'm actually going to leave that there. Okay. Any other questions? Any other questions? Any other questions? Okay. I think I've uploaded all the stuff from chapter 7. Not all of it. I think there's 1 or 2 sections left open for me to put in. So just stay tuned. All right, let's finish up 6.2. Whenever this thing decides to start. No, there we go. Okay. So let me review a little bit for tangent and cotangent. Okay. Both of these have a similar workings to sine and cosine with a couple changes. The first big one is tangent has asymptotes. Okay, we did sort of a quick analysis of where they're supposed to happen. So if you guys remember how asymptotes work, right? It's when the bottom of a fraction is equal to 0. So in this case, for f of x, or this f of x, we couldn't plug in -2 because -2 screwed everything up, right? -2 made the bottom 0, right? This was back from like chapter 3. Okay, so we use the same logic for tangent. Tangent we know is sine divided by cosine. So the asymptotes need to happen when cosine is equal to 0. Okay, and that required use of our unit circle. Let's go back to our unit circle. Here it is. So cosine is 0. So cosine, if you guys notice really quick, is the x portion, right? That is 0 at pi over 2, 3 pi over 2. And that's in just one rotation, right? So there's 1 0. There's another 0. Actually, let me do it this way. That's why I had a swirl here. So pi over 2, 3 pi over 2. We're going to keep going. 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2, 13 pi over 2, and so on and so forth. Whoa. Ignacio.
Yeah. Oh.
Somebody's in trouble. I'm just kidding, man. I haven't heard that in like 10 years. And that's just me thinking back to when I was still living at home. Okay, so that's sort of like the theory behind where the our asymptotes are going to be for tangent, right? That's basically it. That's the only difference out of all this. The phase shift and the midline still work out the same. Okay, so I did an example down here. Well, you guys did the example for this one, 2 tan plus 1, right? So we did the same stuff. The amplitude is 2, okay? So let me go over to the graph really quick. The original point would be right here, okay? But because it's of amplitude 2, it'll go up by 2, okay? And same thing all the way across there. And then here, here, and here. Got it? Phase shift still worked out the same. We still needed to rewrite it. That's the rewrite that's not there. So let me do this. So 2 tangent 4 x minus pi over 4 plus 1. So notice how I needed to do the same rewrite as I did before, okay? Phase shift's the same, midline, y equals plus 1, still the same. Notice how it still operates with everything else the same way, okay? Okay, it's good that we tried this one. So now what I want to do is I want to have everybody try out the next one, the cotangent one. So the cotangent one, actually I didn't cover the cotangent one, did I? Tangent, okay, here we go. Cotangent, okay? Same stuff works out. So if you know tangent, you know how to do cotangent. Yeah. So this is the formula for it, okay? Stretch factor, or the amplitude, is still A, okay? The period is pi divided by b, as opposed to 2 pi divided by b, which is what it was for sine and cosine. Tangent and cotangent needed to be divided by pi. Or sorry, pi divided by b, okay? The domain, x cannot be these, okay? As you guys can see, there's asymptotes there again, right? So we're going to go and see that right now. So cotangent, let's go ahead and do that now. Cotangent is cosine of x divided by sine of x. Okay? So we have the same issue that we had with tangent, where we're going to have asymptotes at specific points, right? They have asymptotes. Let's see. There was a question. Nope. Like I said, you guys can stop me if you guys see something pop up on the chat box and it doesn't look like I had seen it. Stop me. You guys can stop me whenever you need to, okay? So let's go ahead and see where we can fill that in. So same idea. Asymptotes happen when the bottom is equal to 0. So in this case, we need sine of x is equal to 0, right? So that happens. Let's go back to our unit circle. So now, where is sine equal to 0? Right? So now we're looking at the y. Where is the y equal to 0? So that happens at 0, at pi, And that's just two of them, right? So at 0 and at pi, that's two of them. Okay, but since the unit circle is sort of cyclical, we can keep going around and we find the rest of them. So 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, and so on and so forth. Okay, so that answers where we have our asymptotes. So x is equal to 0, pi, pi, 2 pi, 3 pi, 4 pi, and so on and so forth. Okay, and that's where we get our these things. So 0, pi, 2 pi, 3 pi, comma, dot, 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 dot. Okay, and lo and behold, if we look at the graph for this thing, right, this point right here is pi over 2, which makes this one pi. 3 pi over 2, 2 pi, right? 5 pi over 2, 3 pi. So technically, there would be another squiggle right here. There's our asymptote, and then there would be a squiggle that goes straight through here, like, whoa, I like that. Like that. Okay? So, come on, there we go. Let me do an easy one. 3 times cotangent of 4x. So we're going to go ahead and start like we usually do. So the amplitude, or the A, right, is 3, right? What's the rest of the stuff? Period, duh. So, period. The t is now the pi divided by b, just how it was for tangent. So it's going to be pi divided by our b is that 4. So one squiggle needs to fit into pi over 4. Okay, phase shift. None. We don't got one. So since there's no C at the very tail end here, we don't care. Okay, and midline. None. So y is equal to 0 in this case. Since there is no plus something here, since there's nothing there, we don't care. We can move on. So we got all the big stuff. Okay, so now we just got to put it in. So our period is pi over 4. So this is the part where you guys got to get a little clever on how you guys want to graph it. I need one squiggle to fit into pi over 4. Let me go back up here. So let me, there is one, this one, this one, there's one right here, and there's one right here. Okay. So you guys remember from tangent, actually that one should be the important one as well. There's the 0, the pi over 4, the plus or minus pi over 4, and then the pi over 2s, the asymptotes that were really important, right? So if you take a look at your squiggle, right, for tangent, those were that point. Whoa, not what I wanted. Oh, that's cool. Okay. Now it wants to erase stuff that I don't want. Okay. So the important parts, the important points were that one, which is negative 1, 3 pi over 4. And then the one back here is about right there, which is 3, 4, 5 pi over 4. Sorry, I got them backwards. 5 pi over 4, comma 1. It's those 3 points right here. Well, 5 technically. This one right here, that one, this one, and then your 2 asymptotes that are on either side. Okay? So we're going to go ahead and use the same idea for the cotangent one that we're going to try out to do now. Whenever my thing decides to work. How about I turn off my camera? I wonder if that's why it's so slow. Okay, there we go. Okay. So our period is pi over 4, no phase shift, midline equals 0. So my midline essentially has no change. That's still that one. Right? Okay. Pi over 4. This is where I got to get crafty. So I'm going to do is this. I'm going to go 1, 2, 3, 4. Does that make sense? That's going to be my mark for pi over 4. Okay. My amplitude is 3. So if you guys look at how cotangent behaves, right, there's going to be an asymptote right there. So there's one asymptote. There's the next one, 1, 2, 3, 4. There's going to be a next one after that, right? And then 1, 2, 3, 4. There's one right here as well. Okay. My amplitude is 3. So now I'm going to start adding in my points. So now all we got to do is just replicate that tangent squiggle in between each one of those, right? So we know it's got to cross smack dab in the middle, right? Smack dab in the middle, smack dab in the middle. And my amplitude is 3. So instead of going up just 1, I have to go up 3 on either side. So 3 up here and 3 down here. 3 up here, 3 down here. 3 up here and 3 down here. Okay? And now we get to take it back to kindergarten. So I know this looks a little weird, but I think it gets the point across. I am not going to be, I'm trying here, okay? There. Whew. So these are a little stretched out, but everything is still there, right? So now, we know that this is going to be 0. That's pi over 4, right? So now the question is this. How do we get these 3? 1, 2. We need to maybe label those tick marks so we know where they're at, okay? And this is where we go. We're going to grab our period. We're going to do our pi divided by 4, and then we're going to divide it by 2 because we need the halfway point. We need that point right there, right? Okay? And that is going to be pi over 8. So we know that this is going to be pi over 8. Should make that a little smaller. Okay. We're going to do the same thing for the point to the left of it, right, we're going to grab our pi over 8 and then divide that by 2, and that's going to be pi over 16. That's going to be the next one over. So we know that this is now pi over 16. Okay, which tells us this is going to be 3 pi over 16. Okay, so this makes sense because if you choose a nice color, not that one, this one. So this is 1 pi over 16, 2 pi over 16, which is the pi over 8, 3 pi over 16, 4 pi over 16, which reduces to pi over 4. Woo! We had done a lot there. Okay, notice the process is not too different. It's the same idea. The squiggle just changes a little bit. That's it. Only difference. Only difference. Okay. Okay. So what I want to do now is there's one cotangent quick check left. I want everybody to try it. I know it says groups 1 and 2. Don't worry with that right now. I want everybody to try to practice this just to get a feel for how to do it. Okay. So I'm going to break you guys up into your groups. I'm going to do maybe, no, not that. I'm going to do, we'll do bigger groups this time. Yeah. Okay. So go ahead, try the quick check for the negative cotangent one. And I'll call you guys back in a little bit. I'll poke in every once in a while here and there. Okay. No sé si necesitas que me mueva. to lift this up. I like to lift them up because it doesn't look so dark with them down. You want me to put them down? You can say you guys, thumbs up, thumbs down. Okay. I bet you guys are having the same problem as you guys did before. The 4 things to find are easy enough to get. It's just the drawing portion that's still got people like, I don't know what I'm doing. Whoa. Okay, I'm gonna take it. You guys are still cranking the numbers out. Let me mess with another group really quick. I'll come back. Thumbs up, thumbs down. Madison, Jesus.
I know how to get like everything, but it's just hard graphing it. That's why I was gonna wait for you to graph it.
I know.
Yeah.
I want you to try it though. I want you to try it.
Okay.
So let me actually go back to it just to see. Oh, come on. All right, so what'd you get for the 4 things? The amplitude, the phase shift.
So the amplitude I got -1.
Right.
Period is pi/2, right?
Period is pi over 2.
And then for the phase shift, it's do we have a phase shift?
Do we have a phase shift?
I didn't get a phase shift, I think.
And guess what?
No.
Nope, there is one.
There is?
Yeah, because you have a C.
Would it be pi/4
Right.
to the right?
Why to the right?
Yeah.
I
I
know
just
the answer to
guessed
this.
to the
No,
right.
but why to the right? Use the force, Madison. I'm just kidding.
I don't think I can.
So what was the rule way back when?
Isn't it when it's negative?
When it's negative.
When it's negative, what happens?
All right.
Move it to the right.
Right. And when it's positive,
You move it
To
to
the
the left.
right.
Wait, but how
So-
did you get pi over 4?
Yeah, how'd you get pi over 4, Madison?
Well, up top in the little blue box,
Mm-hmm.
it tells you how to get it.
Let me see.
I added the little notes.
Mm-hmm. So,
But I didn't think that I had did it right. That's why I said I didn't get a phase shift at first.
no, you're supposed to get a phase shift. So, always, I should actually add that in. I'm going to add it into the little blue box that you're talking about.
Okay.
Equal to a cotangent of bx minus c divided by b plus d. So you still have to do the rewrite. So you guys remember when you did sine and cosine?
Uh-huh.
You had to rewrite the sine and cosine where you factor out the b.
Mm-hmm.
So if you guys have your notes open, it's there now. Actually, you know what? Let me share the screen. Oh, no. Oh, share screen. Okay, there we go. So this thing back here is the phase shift. It's that c divided by b.
C divided by b.
Yep.
Yeah.
So since you do c divided by b, right, and it's negative, you have to move it in what direction?
So it'd be pi over 2 divided by 2.
Right,
Okay.
which would be pi over 4.
Divided by 2.
And if you guys notice, your guys' problem still has where is it? There it is. So if you do that, right, it's still going to be a minus pi divided by 2 divided by 2, which is not minus pi over 4, right?
Mm-hmm. So that's to the right.
Right, it's going to be to the right. So you guys notice how none of the rules changed, right? So you have a phase shift of negative pi over 4 to the right.
Mm-hmm.
And then what's your midline?
Would that be pi over 2?
Nope. What gave you the midline before?
The little ending part?
Right, is there something there?
No.
So what's your midline?
None.
Well, there is one.
It's y equals 0, right?
Yeah, it's exactly, it's y equals 0.
Oh. Okay.
Yeah,
Okay.
got it?
Yeah.
Okay. So I want you guys to try to mess with it and try to graph it. Even
Okay.
if it's completely like that shit crazy wrong, try it. Okay?
Okay.
I'd rather you guys try it and then we fix it than you guys not try it at all. Okay?
Got it.
Okay. Let me go mess with the last group. Okay?
Cool. Mm-hmm.
Thumbs up, thumbs down, thumbs middle. Everybody's having the same problem that they know how to find the 4 important parts of the graph, right? But just can't graph it for some reason. Thumbs up, thumbs down. One unassigned participant. Hunter. Okay. I'm going to throw him into group 2. Okay. I'm going to take your guys' silence as you're still cranking it out. Either that or you guys, I mean, most of everybody else has gotten the important parts. So I'm guessing you guys are all stuck in the same spot. Okay, so I'm going to call everybody in right now. Let it be. Yeah, that's everybody. Okay. Wow. All right. How was that for people? Thumbs up, thumbs down? Silence. Okay. What I've noticed from everybody was that the four important parts were easy to figure out. Okay. It was actually putting it down on paper that actually had given people trouble. Okay. So let's do that. Okay. So let me go ahead and do this one. Oh, whoops, cancel. That's not what I want. No. Let me share my screen. There we go. So, did I share my screen? Or did it just flicker? Okay. So, like I said, the important parts for this graph, everybody could do, for the most part. It was just putting it on paper that really had people sort of throwing up their arms. So, we still have to do 2 more of these, right? So I'm going to tell this to everybody. I want you guys to try it. Okay, even if you train wreck real bad, like the worst the world has ever seen, even if it is that bad, try it. Okay, I'd rather that you guys try it and we correct it, right? And that you guys have questions after that, rather than you guys not try it at all and just look at me do it. Okay, like I said at the very beginning of the semester, back when we were in school, math isn't a spectator sport, right? It involves you guys trying it out. Okay. Like I said, if you guys do horribly on it, that's fine. I'd rather you guys, do horribly and then have questions to ask me rather than you guys just watch me do it. Okay. Okay. So let's do the 4 things, right? So the amplitude, period, phase shift, and midline. Okay, so I actually have to add a couple things in here. Come on, there we go. A tangent of bx minus c divided by b plus d. So for tangent, just how we did for sine and cosine, where we needed to rewrite it in order to get that phase shift back here, we can do the same thing so we can get our phase shift for tangent and cotangent. Okay, so I've already added in the one for cotangent as well. Okay, so you could still do that b or c divided by b. Write it neater. That looks atrocious. Equal to a cotangent b x minus c over b plus d. Okay, so the same thing works out. Just how we did back in chapter 1, and when we moved to chapter 3 and 4, when we were doing lines and quadratics. Whatever that sign is, right, you move to the opposite direction. So if it's negative, you go to the positive. If it's positive, you move toward the negatives. Okay. That's great. Okay, so let's go through this again. So I am going to do exactly the rewrite first. It's going to be 2 times x minus pi over 2 divided by 2. And then there's no, right? This, so pi divided by 2 divided by 2 is going to be negative. Let me just do the change in here. That's going to be pi over 4. Okay, so now amplitude is still 1, right? However, there is that negative there, so we're going to have to take into account a flip of some sort, right? Period. The t is, sorry, not 2 pi, pi, divided by 2 in this case. So there we go. We have our period. Phase shift, it's going to be pi over 4 to the right. Since it's negative, we move it to the positives, right? And then midline, y equals 0. Okay? So, let's go over here. We get to graph all this stuff. So, what I'm going to do is this. So we're going to start with our phase shift, right? We're going to start with our phase shift. And it's going to be pi over 4. So how about we do every 2 squares is pi over 4, right? Okay. Here's where what we're going to do is this. The pi over 4 plus pi over 2. So this is where I am adding, let me go down here. This is the phase shift, right? The plus the period. And the reason why I'm doing this is so we know where the heck we need to stop. Okay? So, this is going to be pi over 4 plus 2 pi over 4. We need common denominators, right? 3 pi over 4. So here's where, this is why we did this, right? This is why we needed to do this calculation. So we know where to stop, but we knew where to start, but we didn't know where to stop. So if this is pi over 4, that's 2 pi over 4. This is 3 pi over 4. So we know where to stop. We know where to stop. We know what, we know where to start, and we know where to stop. Okay, so we know we have an asymptote here. We have an asymptote here, and just like I said before, right? This thing keeps going to the left and to the right. So we know that we have an asymptote back here. And if we go 4 more, asymptote back there. Okay. Okay. Now we put in our important points. Okay. So our graph would usually go 1 right here, 1 here, and 1 right here. Okay. However, we have negatives to contend with this time around, right? So that means it goes the other way. So instead of going in that direction, they go the other way. They go one here, and one here. The same idea. So let me actually leave the original points at there, and there. So we would have a graph that does this. That is original cotangent, right? But we have a vertical flip because of the negative, right? So that means it'll go the other way. It'll go like that. I know it looks a little weird. So not that one. Okay. So then we continue on with the same thing on the other end. Let me ask you guys something. Is my pen glitching out like really bad for you guys? Or are you guys actually seeing what I'm writing down? Because it's like disappearing on me, which makes me think that something's gonna go wrong right now and my app is gonna crash. No answer, huh? Let's see. Ah, you can see it just fine. Okay, good. Thank goodness. Cool. All right. So it's just on my end, which is, I guess, okay. I know what I'm doing. This is the computer just keeps erasing my points for some reason. I'm like, what the heck are you doing? Up, 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 up. This one is incorrect. I went too far up. Point right there. There you go. Got it? How did that feel for people? Thumbs up, thumbs down. Stop me if you need me. Okay? Easier than sine and cosine? Yeah. You don't have to worry about the next point or you only have to worry about one squiggle and then you know that they repeat. And there's a lot less to keep track of under tangent and cotangent. Unfortunately, we got to move on to secant and cosecant. Okay. However, it's actually sort of like a revisit of what we did before. Okay. Specifically, what I want to show people is this. So I'm going to zoom in on the secant one really quick. Okay. The period for one of these. So the secant graph, put it in purple. The secant graph is the green one. Okay. And the cosine graph is that blue one. Okay. So for secant, right, we know that secant, let me do this, secant of x is equal to 1 divided by cosine of x, right? And just like before, right, for tangent and cotangent, they had asymptotes because the bottom was able to be 0. Same thing here. So secant has asymptotes wherever cosine of x is equal to 0, right? So x is equal to, where is cosine equal to 0? That is at pi over 2, 3 pi over 2, 5 pi over 2, comma, dot, 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 dot. And that we got from the sections from before when we were doing it for sine and for cotangent and tangent. So we know asymptotes live there. Okay? There's a bunch of stuff here. Okay? We're back to our period being 2 pi, right? So 1 period of secant is 2 pi. So in order to find out how much it shrinks, we have to do the 2 pi divided by b again. Domain, you guys can see, is sort of the same thing that we had for sine and cosine, except for this one takes care of our asymptotes. The same idea happens, that there's going to be asymptotes at whenever cosine is equal to 0. Okay, so well, this is the fun. This is the cool part. This is why I say that this is like a review for everything that we did before. Okay, I want everybody to look at this. So there is I'm going to highlight the cosine graph. Okay, you guys see that cosine graph? That's how we use. That's the thing we use so that we can graph secant. So what we do instead is notice how the cosine graph, right, is that squiggle in the middle, right? And then cosine does this stuff. It goes whoosh, and then whoosh, right? So each trough gets a little sort of like U thing attached to it, right? And each peak gets another U thing attached to it, which goes upward, right? So the way that you graph secant and cosecant for both of these, right? Great. My pen don't. Oh, there we go. Okay. The way that you graph both of these, right, is you graph this pen is horrible. It keeps changing color. So I'm gonna do this. So the idea behind both of these, let me put up cosecant at the same time now. So notice the same thing happens. That middle part is sine, right? And the green is actually the cosecant. Notice how they behave the same way. So every peak gets its own little U shape attached to it at that top point, whatever that point might be right there, right? And then every trough gets a U thing facing down. So therein lies the key for how we graph secant and cosecant. We graph the associated sine and cosine function that goes with it, and then later we fill in all the rest of the complicated bits. Okay? So, I want to go ahead and do an example. Graph 1 period of that thing right there. Okay? Cosecant is 1 over sine. So what we're going to do, this is what I'm talking about. We're actually going to graph 2 sine of pi x minus pi over 3 minus 1. So this is now our new problem. Okay? once we graph this one, everything else should fall in our lap. Okay, so for the purple one, right? We're gonna just go ahead and start graphing that. Okay, we can do that just how we were doing before. So amplitude, whoa. So there's gonna be an amplitude, a period, a phase shift, and then a midline. Okay, and the rest of the stuff is, like I said, it's gonna fall in our lap, literally fall in our lap. Okay, the amplitude is 2. Okay, we get that from the very front, the 2 here, which is the same 2 that's there. Okay, period. T is equal to the 2 pi divided by B. So B is pi, so it's going to be 2 pi divided by pi, cancel that out. Our period is 2. Okay, phase shift. So just like before, we can rewrite this. So 2 sine, factor out the pi, okay, x minus pi over 3 divided by pi minus 1. If you do that pi divided by 3 divided by pi, you're going to get 1/3. So we have our phase shift. 1/3, since it's minus, we go to the right. No difference there. And then our midline, -1. So here we go. We have our things to make the sine version, right? Now we're going to go fill in the stuff for the cosine afterwards. So what I'm going to do is, I know I gave you guys a line there. Actually, no, that line is perfectly fine. We'll leave it. Okay, so, okay. So what I'm going to do, we know we need to start at 1/3, right? So I'm going to call that 1/3. Okay. So I'm going to do, now to find out where I stop, right, I have to do the 1/3 plus 2. The 1/3 plus my period, right? And that's going to be 1/3 plus 6/3, 7/3. So I know that we need to stop at 7/3. Okay, so this is 1/3. 1, 2, 3, 2/3, 3, 4, 5, 6, 7. This is going to be 7/3. Okay. Okay. Midline, -1. So what I'm going to do is, I'm actually going to put these tick marks down or up above it. So 1/3 and 7/3. I'm going to grab my midline. I know my midline is right there. Okay. So we've done, let's see what we've done already. Midline, phase shifts, period. The last thing that's left is our amplitude, right? So we're still looking at this over here, the sine version of the graph, right? So it's +2, so we go up 2 and down 2, right? And since it's positive, you know it goes up first, then down. So this is going to be a little wonky here, but it's sort of semi already done for us. We know that it's supposed to cross right here. That's in the middle, right? There is no middle point here, but we can sort of gauge. We know it's going to be around right here, right? And then, whoops. Look at me go. It's off the midline, right? So we know it's supposed to cross there, right? And it's supposed to go from our midline up first, then down, right? So we know it crosses there. We know it crosses there. Up to, and it's going to be up to halfway, right? And come back down. And then down to, at that middle, and then come back up. Okay? So now we actually graph the sine one. So I'm going to go ahead and graph it, okay? And this is just to connect the dots. Okay? Now, let's go ahead and keep going with our graph, okay? So I'm going to count out, let me see, +6 more, right? So 7 over, that's going to be 13. So 7, 8, 9, 10, 11, 12, 13. So this is 13 divided by 3. Okay, so we know, same thing. Those are the 3 important points, like the middle and the end, right? Our halfway goes up to here, and then halfway goes down to here. Notice where I'm putting my dots, right? The sine, I'm going to continue the squiggle up, back down, back down, back up. Okay, so notice what I did. I have 2 periods worth of sine, the sine version. Does that make sense? All right. Now comes the fun stuff. So we need to now graph cosecant, right? So notice where, let me go back up to the graphs. So what I want people to notice here is, let me erase all the extra bits. If you go and take a look at where it crosses the x-axis, where the sine or the cosine in this case, either one, where the sine or the cosine crosses the x-axis, we have an asymptote. Got it? So let's go back to our graph. We know we have asymptotes here, here, everywhere where it crosses the midline. You guys notice that? So I'm going to start drawing my asymptotes in to help me guide my picture a little more. Okay, and now is the fun part. You just get to fill in the rest. So the green is actually the final cosecant. Whoa. Okay, and like I said, this thing keeps repeating, but I'm not going to go ahead and do that. Right? Okay. So notice what automatically we got, right? Just from doing all of this, right? The yeah, asymptotes, right? Let me put it up here. We have asymptotes at 1/3, 4/3, 7/3, 10/3, 13/3. Okay, and you can do that by just counting off the thirds, right? So that's 1/3, 2, 3, 4/3, 5, 6, 7/3, 8, 9, 10/3, so on and so forth, right? Domain. The asymptotes give it away, right? So all real numbers, right? X cannot equal the asymptotes. 1/3, 4/3, 7/3, dot, 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 right? And lastly, the range. My Y values, I never labeled the Y, so that's actually going to be 1, and that is actually going to be -3. So this is where you get the real funky ones. So negative infinity all the way up to -3 in this case. And we will include it because it actually gets to that point. So see this point right here? It actually hits it. It actually hits it there. Okay? And then that's only half of it. Union 1 to infinity. We'll include that point there. Same thing up above. It actually hits this point. It actually hits this point. So there we are. So notice, right? It's basically all the stuff that we've been doing already, plus a couple more things, right? Specifically at the end, we just add the u's once we finish graphing the regular sine or cosine graph for it. So since this one was cosecant, which is 1 over sine, that's why we needed to do sine. Okay? If we wanted to do a secant graph, then we'd have to do 1 over cosine, right? So we'd have to graph the cosine version of it. Okay? So I'm going to skip that one. Actually, I think I've talked enough. I want you guys to go ahead and try the lecture questions for a little while. Okay? Are there any questions before I call this section done? Okay. I want to give everybody, come on. Yeah, I want to give everybody maybe 20 minutes to finish this. To finish the lecture questions. I'll be on. I can hear you guys. I'm going to go get some water. But I'll be around. Okay? I want to give everybody a little bit of time to finish up the lecture questions. See how far you guys can get on it. Okay? How are people doing? I know that tail end was a little harsh. Like I said, nothing you guys haven't seen yet. It may require you to go back and visit the stuff for sine and cosine, which is section 6.1. So if you need to, go do it. Said, stop me if you need me. I'm here. I have my headphones on, so if one of you guys shouts at me, I'll be able to hear you at least to get my attention, and then I'll come back over to the computer. Floating around, organizing my stuff here and there.
I have a question on number 1.
Yeah.
So the amplitude is just how high the point is going to be from like the midline, or where the
Exactly.
midline is?
Right.
Okay.
It's technically not called the amplitude, but we're treating it the same way. So that's why I keep on calling it. I know the notes have said there is no amplitude, but it's acting the same way, exactly the same way. People still doing okay? Like I said, you guys can stop me.
For number 2, what does it mean about graph on the interval 0, 5?
For which one? Number
Number 2.
number 2. So when you do, yeah. So the period for this is going to be 0. The period for this is going to be, 10, right? And I just want you to graph from 0 to 5.
All right.
So the period's going to be 10, right? You know, halfway in between the period for tangent, there's an asymptote, right?
Yeah.
So I only want you to graph it up to the asymptote. You don't need to do the rest of the stuff.
All
Does
right.
that make sense?
Yeah.
You're doing all right. If you're doing okay, tune me out. I won't feel offended. Oh yeah, this is all getting to me.
For the second graph on number 1,
Yeah.
how would we? I'm not sure how to label like the periods.
Hmm.
Would we?
So what'd you get for the period?
I got 2 pi over 5.
Right. So for that, let's see. Okay, so let me Let me go back to, because that's a hard denominator to do, right?
Mm-hmm.
That's probably what's tripping you out. So let's go back to 6-1. And let me go back to, so you know, I should make that small. There we go. You know, one squiggle, right,
Mm-hmm.
has to happen in 2 pi divided by 5, right?
Yeah.
And there's technically, so from the start, right?
Uh-huh.
So right from way back from where you start, you have to divide it 1, 2, 3, 4 times, right?
Mm-hmm.
Does that make sense?
Secant? Wouldn't we use cosine
Huh?
for secant?
Yeah, you would use cosine. So no, yeah,
Okay.
it doesn't matter. I was so both of these have a period of 2 pi. You're right, you do need cosine, right? So from the beginning to the end, you need 1, 2, 3, 4 sort of divisions, right?
Mm-hmm.
So grab your period, the entire period, right? And divide it by 4, just so that you know sort of how big each one of these is supposed to be. So each one of these breakups are supposed to be. Does that make sense?
Yeah. So I got pi over 10.
Right. Does that make sense?
Yeah.
So how about we do, so let me attaching stuff from my computer. Okay. So for that one, how about we do like every 2 is a pi over 10,
Mm-hmm.
right? Pi over 10, sorry. Right? 2, 3, 4, 5. So, yeah, 2 pi over 10, right?
Yeah.
3 pi over 10, 4 pi over 10, 5 pi over 10, right?
Mm-hmm.
So then, do you have a phase shift?
No phase shift.
No phase shift. And you know that you have to go all the way to so the period that you got, right, the t
Mm-hmm.
is 2 pi divided by 5, right?
Uh-huh.
And it just so happens to be,
4 pi over 10. Oh, okay.
right? So notice we didn't have to go that far.
So that's where one period should fit between pi over 10 or wait,
It should go all the way to 2 pi over 5.
which is 4 pi over 10, right?
Right.
And do
So-
we,
Do you,
since it's a cosine, we started, do we start it at the 0 y-axis? Or do we start at pi over 10?
do you have a phase shift?
No.
Nope. So you would start it along this axis right here.
Okay.
So you know that this is going to be your period right here.
Yeah, it's gonna fit between all that. Okay.
Between, yeah.
Okay, got it.
Yeah.
Yep.
So when you graph these, you got to be a little crafty on how you get the extra points or the other points that you need. Whew. And just the FYI, I chose every 2 for pi over 10 just because. You could have done every 3 for pi over 10 or just had 1 for pi over 10. That would have made your graph a little bit tighter, right? But it would have still done its job. I'm just sort of given enough space so that I can do, I can allow for the rest of the stuff. You don't want it too compact where it doesn't make sense when you look back at it. So what did people do over the weekend?
Celebrated my birthday early.
Man.
I
My
still-
birthday is in 2 days.
My birthday's actually today.
Oh, happy birthday!
Thank you.
Happy birthday. Feliz cumpleaños.
Thank you very much.
Do you guys, well, if you don't mind my asking, you're Filipino, right?
Yeah.
Do you guys also say Feliz cumpleaños, or you guys have something similar?
I don't really talk in Tagalog, so they
Okay.
talk to me in English. So
Oh, okay.
I would have to ask my parents.
Yeah. There's another faculty member in the department. His name is Diwa. Diwa and I used to be the lab coordinators up to maybe, he was there for 2 years. I was there for 5. But we got to learning about our languages. And there were times, so there's another Filipino instructor that's also with us for part of the faculty. Her name is Ms. Magante. And sometimes they would be talking, and they would be talking about stuff. And because Tagalog is like half Spanish, almost half Chinese in a sense, half like the native language of the Philippines.
And some Indonesian in there.
Yeah, and some Indonesian. They're all thrown in there, right?
Yeah.
Sometimes I would listen to them like talk, right? And I would listen to them talk, and I would start picking up stuff because it like some of the stuff that's in there is in Spanish. So and sometimes they'd be like, they'd be talking about a meeting of some sort, right?
Mm-hmm.
And without any like, how'd I say it? Without
Context?
a pause.
Oh, okay.
Yeah, without, let me not say context, because we all, what ended up happening was we knew the context, right?
Mm-hmm.
Without any pause, they'd be talking in Tagalog, and I'd butt in and was like, yeah, I didn't like that meeting either, man, because I understood what they were saying. And they're like, oh, wait, because you understood what we were saying. I was like, yeah. It's happened multiple times where, like, it's gotten down to the point where when Diwa and Marie and I, if we go into a meeting, or if we're like in the same rooms together, they would speak in Tagalog, and I would speak in Spanish, and we would be able to understand ourselves perfectly well. And then same thing, there used to be a tutor. She was Brazilian, so she spoke Portuguese. Same thing. Like she would talk in Portuguese, and we'd be able D1 and I we'd be able to pick it up. So it ended up becoming a little bit like so if you guys have watched Ocean's 11 or 12 or 13, I can't remember which one it is. There was that tiny little Asian guy that was the ninja. He would speak in, I think it was Japanese. No subtitles would show up in the movie, but then everybody would answer him in English because they understood everybody. So it ended up becoming like that. So the Filipino instructors, me speaking Spanish, and the one Brazilian tutor that we had, would be speaking in our own languages. We'd sort of semi be able to understand each other.
That's funny.
Yeah.
I just imagine just walking into that.
Right?
Just like 3 different languages going on, and just
Yeah.
answering back to. It's
Yeah,
like,
and then just answering back and forth. What else did people do over the weekend? I did baking. I baked something. I made, now listen to this, because I think I'm onto something here. Chocolate chip, walnut, banana nut bread. I know.
I think I've seen the recipe once.
Dang it, yeah. Well, the original idea was I was gonna just make banana nut bread. I had walnuts laying around. I was like, oh, I can add nuts. Why not? And then I had made, this was from like months ago. I made cookies. I was like, I got chocolate chip cookies. Oh my god. How are people doing? Doing okay? You guys still stumped on some stuff?
I'm just waiting for the next one because I just it's gonna be too much effort because I came in here super late.
Oh,
Yeah, so I'll
That's
just
okay.
I'll just rewatch
yeah.
the thing.
All right. I haven't given you guys a break. So if you guys are still working on this stuff, keep working on it. If you aren't done, go ahead, take a break. Go have yourself a nice moment. Go get some tea, coffee, whatever you need.
Oh, real quick.
Yeah.
So the pi over 10, is
Yeah.
that just because we found what it was equal to when you divided it by 4? So you just counted by that
Right. Exactly.
number?
So
Okay.
so the period, right?
Was pi over 10?
Not pi over 10.
Oh.
The period
what
is
was
going to be the 2 pi.
I'm in class.
Oh, sorry. Happy birthday.
Thank you.
Yeah, happy birthday. The period is the 2 pi divided by 5, right?
Yeah.
Okay. So what we did, so that's the entire period. That's where one squiggle has to happen, right?
Mm-hmm.
So what we did was we divided it by 4 so that we knew where the important points were going to be. So let me switch back to, what was it, 6-1?
Okay.
So if you take a look at sine and cosine,
Mm-hmm.
right? So if you take a look at sine and cosine, it's divided into 4 parts, right?
Mm-hmm.
So that's why we divided it by 4. So we can find out where those 4 parts are. Does that make sense?
When you divide by 4, is it like one part of it?
Right, exactly. So that's why, so let me do,
So if you want to do 3 parts, it would be divided by 12
by 3.
or
Yeah.
3.
Yeah.
Okay.
So let me actually get rid of the
Oh,
highlights
4
here.
for the whole thing. Okay.
Right. So notice what happens, right? So let me
Yeah.
do the math on the side here. So 1 period for cosine, right, is 2 pi, right? So what we're going to do is we're going to grab the 2 pi and we're going to divide it by 4. That's going to be pi over 2, right? So each quarter, right, each fourth of our graph is going to be, excuse me, each quarter is going to be pi over 2 big, right?
Mm-hmm.
So if we start at 0, right, then we go 1 pi over 2, right,
Mm-hmm.
2 pi over 2,
Mm-hmm.
3 pi over 2, 4 pi over 2. So see how I counted them out, right?
Yeah.
Okay. This one is already done. That's pi over 2, right?
Mm-hmm.
This one is, if we reduce it, right, we get pi.
Mm-hmm.
You
Okay.
see that?
Yeah.
3 pi over 2, that's already done, right?
Yeah.
And then the last one, 4 pi over 2, if you reduce that, that becomes the 2 pi that we need down here.
Okay.
Does that make sense? So the same idea happens over here in here, right? So our period, right, our t is 2 pi divided by 5,
Mm-hmm.
right? So we need to know how big each quarter is, right? So and that's why we did 2 pi divided by 5 divided by 4, right? And if you do this right, you get pi over 10. So we know that each quarter is pi over 10.
Mm-hmm.
That's why we did this thing right here, right? So pi over 10, 2 pi over 10, 3 pi over 10, and then finally 4 pi over 10. That reduces to 2 pi divided by 5.
Okay.
Right?
Yeah.
So now we have our quarter divisions, right? We know that a portion fits in here, a portion fits in here, something else fits in here, and something else fits in here.
Okay. Okay.
Got it?
And then all your junk goes in there.
Yep.
Okay. Thank you.
Uh-huh. Okay, like I said, go take a break. Got another 5 minutes. So something fun I did over the weekend. Oh, we have chat stuff. What? Nuts in anything ruined dessert? Boo. What? 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 F for the day. F for the day. No, I enjoy having the walnuts in there. It's not even debatable. Oh my god. Are you somebody that doesn't believe that pineapple belongs on a pizza either? I love that shit. Yeah. I have not found somebody. Everybody loves Hawaiian pizza. At least everybody I know loves Hawaiian pizza. So yay. So something fun that I did over the weekend, which is something I've been wanting to do for like a while, is let me show you guys. Choose virtual background. Let's do none. Here we go. Okay. So my backyard, it's not really a backyard. It's like, so I live in an apartment complex. So this is it. Ta-da. Right? I installed that thing. So now I got like a little canopy area, and it's really nice now. Like, because out here you're actually like in the sun. So we couldn't really use our backyard for pretty much nothing really. But now, because of the shader, I can be outside. I can chillax on my my little patio area. And I think that's cool. And that way, at least. Did I buy it? No, I actually went to Costco and got it. And I did like a bunch of like, I pulled a semi MacGyver thing where, so I went to Home Depot. Let me show you guys what I did. No, wrong one. Okay. So I went to, I don't know if you guys can see it, but it's on a dowel. And then I put some hooks in, put a screwdriver or screw in. And hooked it up that way. So now it's on a dowel. I can roll it up, so it's it is you can roll it up manually at least. So but it's cool because now I can hang out outside and not have to be indoors the whole time, which is the thing that bothered me a lot. Because after being in a room, because all I have is like my living room, my bedroom, the dining room, which is attached to the living room, kind of, right? And then the kitchen. After a while, you get crazy about just staying in one of those rooms. Yeah, you can. But sometimes it's just like, I don't want to go outside. I want to be outside in my own private area. Like, you just want to, just sit outside. Like, not with people. Edlin has a question number 2. Okay, go, shoot.
Sorry, didn't want to interrupt your story.
Oh, yeah, no. You stop me whenever. I'm just blabbering
right.
stuff, so.
For number 2, so for the period, I got 10, but
Yep.
it says to graph on the interval 0 to 5.
Yep.
So is that so we don't have to graph the second half of the
Exactly.
period?
You don't have to graph, right? You don't have to graph the thing that happens after the asymptote.
Okay, got it.
Got it?
Yeah.
Thanks, Miguel. I hadn't seen it. I just saw your comment. Like I said, if you guys need to stop me, stop me. even if I am like showing stuff off. Ooh, 6 pages. Oh. All right. I have to move on. I'm having myself my banana nut bread. All right. Okay. Mm, mm, mm. All right. Got maybe 40 hours, 40 minutes left of class. Let's see how far we can get on 6-3. Okay. So we've talked about trig functions a bunch. We've graphed them. Like I said, from the beginning of the semester, a couple weeks in, every function, everything you can possibly think of, we'd want to ideally have an inverse for it. Okay. So every function, if it does something, we want something that'll undo it. Okay. So likewise for trig functions, there are inverse trig functions. So that's what this section is gonna deal with. The heck, the inverse functions for trig. What the heck the inverse trig functions are all about, and the specifics for all of them. Okay. So let me plug myself in really quick. So to begin with, the way that we find out if two functions are inverses is if f compose G of X, right? If you guys remember what that is when you grab G of X, right? And you stick that inside of F, right? That has to be equal to X. So the idea behind it is, so X is your input, right? G of X does something to it, and then F of X undoes that thing, whatever that is, right? Okay. Back in chapter 1 or 2, I think it was, there were some pretty cool properties about inverse. That the domain of F becomes the range, right? Actually, let me do this. Domain and range, right, became the range slash domain of F. So if F had a domain, that became the range of F, right? And if F had a range, that became the domain of F, right? So if we take a look at how the trig functions worked, right? The domain was negative infinity to infinity. You were able to plug whatever you wanted to them, right? Okay. And then the range, all of these were, oh, sorry, domain, this is going to be negative infinity to infinity. X cannot equal, so you guys remember this, right? Pi over 2, 3 pi over 2. This is where the asymptotes were. 5 pi over 2, comma, dot, 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 right? Okay. The range for sine and cosine, those were easy. Negative 1 to 1, negative 1 to 1. And then the range for tangent, that was negative infinity to infinity. Right? There was no y value that we could not hit. Okay. So essentially, right, the domain were all the angles and the range were all the values, right? So for inverse trig functions, right, basically both of these switch. The domain is now the range and the range is now the domain. So sine and cosine, or inverse sine and inverse cosine, there is a little switch that happens here, okay? The domain for sine, and there's a problem here. So you guys remember F inverse and F needed to be 1 to 1, right? So the problem here is because sine and cosine, right, they squiggle, right? They can't be 1 to 1. If you draw the horizontal line, right, it hits twice. So that means for every y value, there's more than one x value. Got it? So what did we do back then? What we had to do is what we call restrict the domain. Okay? So that comes down here. We need them to all be 1 to 1, right? So we need to restrict their domains. Okay? Yeah. I'd rather put them down here. Okay. The inverse, the idea of the inverse still works out. Okay, so for example 1, if sine of pi over 6, we can get this from the unit circle. If this is 1/2, right, then sine inverse of 1/2 is going to be my pi over 6. Okay, and likewise for cosine, if cosine of pi is -1, then cosine inverse of -1 is going to be pi. Okay, notice we get these all from the unit circle. Okay, now here comes the toughie. Okay, we need to restrict the domains for sine inverse in order to have an actual inverse. We need it to be 1-to-1. Okay, and the way that we do this, okay, is we're going to go back to the unit circle. Okay, I'm not going to draw the whole thing out, but I'm just going to draw enough of it so that we can, whoa, how about shape? Yeah, that didn't work out, but it's okay. Oh yeah, a little straighter. There we go. All right, we have our unit circle, right? We're going to look at sine first, okay? All the possible values of sine go from -1 to +1, right? The angles that do that are, so we're going to go from down here all the way up here. So that's from -pi/2 to pi/2, okay? So what we're essentially doing is, we know that sine, let me go over here, the sine squiggle, right? It goes up, down, right? And the same thing over here, right? From -pi/2 to pi/2, from here to here. That's the entire gamut of values that sine can take. Does that make sense? So we only need from -pi/2 to pi/2. So our domain, right, is going to be -1 to 1, and our range, the thing that this thing spits out, is -pi/2 to pi/2. Okay. Same idea with cosine. So let me go ahead and do the thing for cosine now. So let me shape. Stop me if you need it. Okay. So for cosine, so notice this, let me put this up here. Cosine theta comma sine theta. Okay. Sine dealt with the y values, right? So we needed to go from as far down to as far up as possible. That was done from -pi/2 to pi/2, right? That was for the y's. Now we're dealing with the x's, right? So this one was sine. Now we need to do cosine theta, right? Funny. I thought I was trying to shape. I wasn't. Okay. Now we need to do cosine, right? That deals with the x's, right? So from as far positive on the x to as far negative on the x, right? So those values go from -1 to 1, right? So -1 to 1. Now the range is just how we did from before. It's from here to here, whatever that angle is. And it turns out those two angles are there. So my range is from 0, 0 to pi. Oops. Okay. For tangent, it's actually easier to look at the graph of it. So let's go ahead and do the asymptotes. Okay, so we know -pi/2 is the first one, pi/2 is the second one, right? And we know the tangent squiggle goes, right? Okay, we want to invert this. The domain, right, now is -infinity to infinity. So tangent, the range was -infinity to infinity, right? So it can go as far down as it needed to, and it can go as high up as it wanted to, right? So any y value can be attained. But in this case, in order for it to be 1 to 1, right? So remember, this thing keeps squiggling after this, right? So we have a squiggle here, we have another squiggle here. If we start including all those other squiggles, we don't have 1 to 1, okay? So we just say, we don't want those. We just want the one squiggle from the very beginning. So my range is going to be -pi/2 to pi/2. This will ensure that we actually have inverses for our trigonometric functions. Okay? Okay. So we're going to go ahead and practice some of these, and then I'm going to send you off to do some a quick check. These are not numbered. These should be a little, these should be simple enough to do, okay? So this one, we need our unit circle, okay? So if we need sine inverse of 1/2, what we're going to do is we're going to go back to our unit circle. Get rid of our mathematical incantation there. Okay, there we go. So I want to find sine inverse of 1/2. So how about I do this instead? So I want sine of some angle theta to be equal to 1/2. This is an equivalent thing to do, right? So I want the angle theta so that sine of it is 1/2. I'm going to go back to my unit circle. Sine of 1/2 is right there. Actually use the highlighter, is actually right there. So my angle is pi/6. So theta, right, which is sine inverse of 1/2, is going to be pi/6. And we're done. Okay. Now, to just double check, right, this value right here, my pi over 6, it has to exist in the range for sine inverse, right? And if you take a look at the unit circle, we just have to exist somewhere in between here, which we do. We're good, okay? Sine inverse, negative root 2 over 2. So and that means, let's go ahead and go back to, we can rewrite this, right? Sine of some angle is equal to negative root 2 over 2. Okay? Now, there's a reason why I didn't mention this before. If we go back to our unit circle, we need sine theta to be negative root 2 over 2. Okay? That happens here. That also happens here. You guys see that? Okay. However, we need, in order for the inverse to happen, right, we need it to exist specifically in here, from negative pi over 2 to pi over 2. Okay? So that automatically disqualifies this. We can't have that one, which means this one is the one we're going to choose. Now, this one is 7 pi over 4, right? We do have to do a little finagling with this because 7 pi over 4 is if we start here and go all the way around and stop at that angle right here, right? That's not what we need. So instead, we're going to do the terminal angle thing, right? And this time we can go ahead and go negatives if we need to. So if we start here and we go down, that's negative pi over 4. So we'll go back to our page. This tells me theta is the sine inverse negative root 2 over 2, which is negative pi over 4. So notice how this is working out. I am choosing it to be within a specific value, within my negative pi over 2 to pi over 2, okay? There may be more than one angle that will do whatever this thing is saying, right? But you have to make sure it reduces down to where the domain is. Sorry, where the range is, okay? So this one, cosine of some angle theta is negative root 3 over 2, right? So we go back to our unit circle. This is why I'm not making you memorize it. I'm thinking you will use this so much that you will memorize it anyway. Okay, cosine, right? That means we need the x portion. It needs to be negative root 3 over 2. It happens there, and it happens there. Okay? But for cosine, the range has to be from 0 to pi, between here and here. That's it. Automatically disqualifies this one. So it's got to be this one. We know which one that does. 5 pi over 6. So theta is the cosine inverse of negative root 3 over 2, 5 pi over 6. Okay, last one, tangent. So for tangent, same idea. We can rewrite it. Tangent of some angle theta is equal to 1. Okay? And this has to also equal some sine theta divided by cosine of theta. So that's the thing that we're going to use to find what point or what angle we need to be looking at, right? So that means sine and cosine need to be exactly the same if we want them to divide each other and make it equal to 1, right? So we go back to here, right? So we want where sine and cosine are equal. And that happens in only one spot. Sine and cosine are equal right there, which means our angle is pi over 4. Since we need it to live between negative pi over 2 and pi over 2, that's legit, right? There's actually another spot where it actually happens, and that's down here. Negative root 2 over 2 divided by negative root 2 over 2 is also 1. But since it's not between negative pi over 2 and pi over 2, we are done. This one becomes disqualified as a choice. It's got to be this one. So my theta is pi over 4. Okay, I want you guys to practice this a little bit. I am going to give you guys maybe 5 minutes to try it out. I'm going to put you guys in some breakout groups to try this out, and I'll poke my head in here and there. Okay. Oh my. Okay. And go. I think it's enough for both of us. Because you're gonna eat the chicken, right? We want to go for dinner. ¿Quieres hacer algo acá otra vez? Bueno. Every day there's less and less of you. How you guys doing? Doing all right? Is something still tripping you guys out? You guys have been very quiet. Let me go bug another group. Jarek, Mohammed,
Yes, to me.
just you. Well, Mohammed's supposed to be in here too, but I think he has a lot of problems with his mic, so that's why he's not joining.
Mm.
Yeah.
So, since it's -1, does it go the opposite way?
Uh,
Or does it go to 90 degrees on the
for
unit?
which one? For
Tangent to the negative power -1.
right. So what angles make that happen?
Is it 0, 0, and 1? Does like oh no, negative. Does it go? I don't know.
Look, so yeah, take a look at your unit circle, right?
Yeah.
So did you do the rewrite? So that implies that tangent theta is equal to -1, right?
Yeah.
So that means you know that tangent is sine over cosine, right?
Mm-hmm.
So that means sine divided by cosine. So that means sine and cosine have to be
the
equal,
same. Yeah.
right? With the exception that one of them needs to be negative, right?
Mm-hmm.
Either sine has to be negative or cosine needs to be negative, right?
Either or, it can't be both.
Well, if it's both, then you have a negative divided by a negative, which makes it
A positive. Oh,
positive.
okay. Okay.
So you can't have where they're exactly the same. You have to have where one of them is negative from the other,
Okay.
right?
I don't.
Where-
I get that part, but I don't
Mhm.
get my starting point.
So this is where you go to the unit circle.
Yeah,
Where
I'm
on the
looking at
unit
it.
circle do you have sine equal negative cosine, or negative sine is equal to cosine? Does that make sense?
Yeah, I see them. I just I don't know which
What
one
angles? Which angles are they?
to angle one or degrees or angles.
Well, yeah, the degrees or the angles, whichever one.
135 and 315.
Right. So 3 pi over 4 and 7 pi over 4,
Yeah.
right? are the only two angles where you get -1 for tangent, right?
Mm-hmm.
Which one's the right one to choose?
So I go. Is the -1 gonna be my x or y? I is it is the -1 my y?
What do you mean?
For the 0 and negative, or negative and 0, for the
Mm,
180 and for the pi squared and or pi over 2 thing.
so which one of these angles is the one that you'd want to choose? So how about
I would say 3 pi over 4.
Huh?
3 pi over 4.
Why that one?
I don't know. It's a good.
So what's the range, right? What is the range of tangent? Where does so if we look over here, right?
Mm.
Tangent, let's go back up here. Tangent needs to live in -pi/2 to pi/2.
Negative pi over 2 to pi over 2.
Right. So it needs to live somewhere between, actually, I just erased it. It needs to live somewhere between here to here.
I don't see your screen, by the way.
Oh, haha. Let me erase really quick and then share my screen.
Okay.
So it needs to live somewhere between here and here, right?
Mm-hmm. Oh, okay. So. Oh, okay.
So like you said, there are two of them. There's that one.
So it'd be 7 squared over 4.
Right, but you need to give me the negative angle for that one.
The negative angle?
Yeah.
Oh.
So remember, it needs to go, technically we're looking at this from here to here, right?
Mm-hmm.
-pi/2 to pi/2, right?
Yeah.
What would this angle be?
What would that angle be? Wouldn't be those two numbers? No.
So I think you said earlier that it would be, what is that, 7 pi/4, right?
Mm-hmm.
But since we had to go one way around, right, we can't do that
Oh.
because of the range. So we needed to drop down. How big is this angle?
45. Or,
Right.
yeah.
So then how big would this angle be as you go downward?
-45.
-45. We're done.
Okay.
Got it?
So it would be zeta equals 10. Oh, just 45.
Right. Well, -45
Yeah, -45. Yeah.
or -pi/4.
Okay.
Let me call everybody back, okay? So I can cover
Okay.
this really quick.
Okay.
It might have seemed like this might have been the last straw for everybody.
I don't want to think. I just don't want to think today.
Yeah, I can dig it.
Oh, speaking of which, can you give me more late passes, please?
I don't know, how many do you have?
I've been going through old work, and I got like at least 2 more goes. I think. Yeah, so
Okay.
I'm gonna need a little bit more.
Yeah, I can add them for now. Is this everybody?
Shouldn't be.
Yeah, this is everybody actually.
Oh, okay.
7 people. Like I said, this might this trig stuff might have been the last straw for a lot of you guys. Share my screen. Let me cover these really quick, and I'll let you guys go. Okay.
Okay.
So, like I said, your guys' homework assignments online are already there, so you guys can go ahead and try them out.
Hmm.
So, this is equivalent to sine of theta is equal to -1. Okay. If we look at our unit circle, that happens down here. Ooh, that's a lot of drawing. Actually, I think I'll just cover this one, and then I'll let you guys go. That happens down here, right? And that just so happens to live where we need it to. So then that means theta is equal to sine inverse of -1, which is negative pi over 2. And we're done. All right, I think you guys are pooped. I think you guys are done for the day. I'll pick this up on Wednesday. Hopefully we can get through the rest of this and then maybe start 7-1 on Wednesday. Okay?
Okay.
Besides that, wash your hands, be safe, and I'll see you guys in 2 days. Make sure you do your homework online.
Make sure to give me more like this.
Yeah, I know. I'll give you more late passes.
Okay.
At the
thank
moment, you can go ahead and keep, I mean, the chapter 6 stuff and the chapter 7 stuff, it's up for people to try out.
you. Okay.
Cool?
Cool.
Okay.
See you.
See ya. Mohammed, I saw your email. I can't particularly remember what it was because I was doing a lot of emails just now. Let's see. What was it? Oh, your exam stuff. I have it. I haven't looked through it yet. That's why. So I need to go in and for your email and look for it. Okay. But you're one of the few people I think that I need to do to review the exam with, and then after that, I'm done. Okay. Unless you have a question, I'm going to go ahead and close it up for everybody, and I'll put up the recording in a little bit. Okay.